So what is Gyraline? Well, I'm glad you asked. How does this magic work that allows a phone to get toe, camber, and caster? Well, it's actually pretty simple. Using your phone's sensors and our patent-pending Gyraline system, Gyraline is able to build a system of planes in 3D space. So let's look at an example of how to take a toe measurement. We're gonna start with the rear left wheel. Put your phone into measurement position, making sure that Gyraline is parallel with this wheel. When you touch the wheel, Gyraline will set that plane in 3D space and be ready to calculate an offset from that plane. So we're gonna go around to the other side of the wheel, keeping the device pointed straight, and take a measurement of the rear right wheel. Now we're gonna go back to the wheel we started at, and we're gonna get one final measurement for that plane. This sets everything up to get a very accurate measurement of total toe on that axle. Then we're gonna do the exact same thing for the front. Now the last step for this mode is to compare one of the rear wheels to one of the front wheels. This will get an offset of the average vector for the front and rear planes. The difference that you see is basically your steering wheel offset. If you get this even, your steering wheel will be straight. If your wheels are pointed like this, your steering wheel is actually gonna have to be pointed to the left in order for the car to go straight. And the opposite with something like this. We want them to be dead straight. While this mode is fast and can get the alignment pretty close, it doesn't accurately compare the wheels to the body. For that, we developed a completely different way of doing an alignment called body align mode. Body align mode works with the same type of plane system, except it grabs some references from your car's surface. What sets this mode apart from other DIY alignment systems is that it actually aligns the car, not just the suspension, which means you're gonna get a true thrust angle instead of one laden with assumptions about the car's hardware. Gyraline will grab two reference planes from your vehicle and calculate what the theoretical straight line is through the car. It will then compare this line to all four of your wheels to derive a true thrust vector. So let's talk about how camber mode works. You'll definitely want to set your camber first. Camber mode can do all four of your wheels one at a time. Just tap which wheel you want to do, rotate your phone 90 degrees, and place the phone up against a wheel in a manner where it's going to be parallel to the wheel face. You can use the slider on the left to increase the amount of samples that are getting averaged. This will make the reading more accurate. Once the measurement stops wandering around, press save. The camber shows up, and now you can go to all four wheels and you should see cross camber numbers. You may notice at the bottom here, it says uncalibrated device. That's because the sensors in every single phone are slightly offset, so your readings might be a little bit off. Think 0.1 to 1.0 degrees off from the true camber, but it will still be able to compare wheels to each other and get an accurate cross camber, which is one of the most important measurements that determine how a car drives. Soon, you'll be able to tap this button here and calibrate your device right at home. That's a feature that we're working on. Camber's easy enough, but what about caster mode? Well, the current version of caster mode takes 6 reference points. Caster mode takes a little bit longer to explain because it uses a little bit of trigonometry to derive what the actual caster is on the vehicle. If you want to learn more about how to do it and how it works, click this video here. Ackermann mode is extremely simple. We're just going to put our steering wheel perfectly straight, take a measurement of the toe, turn the wheel to the right as far as it will go, and take the front left wheel and front right wheel's toe measurement. Ackermann mode will calculate how many degrees of toe in or out your vehicle generates per 10 degrees of steered input. This is extremely important for drift cars and race cars. Street cars will usually gain toe out as they're steered, and a lot of race cars will actually toe in as you steer the wheels. Used correctly, Gyraline is accurate up to 0.05 degrees or 1/32 of an inch. This is for toe. Camber mode's precision is down to 0.1 degrees. Gyraline Professional, which is currently in development, is precise down to 0.02 degrees or a little bit closer than 1/64 of an inch, much tighter than the human eye could even see on a ruler. We invented Gyraline because we are so tired of inaccurate shop alignments, messing with those stinking toe plates, trying to read the tape measure, and setting up those string alignments. We built this for the car community and we listened to everybody's feedback on pricing. So we have two ways to get into Gyraline. We have a pay-per-use model for enthusiasts that aren't going to use this very often. This keeps your cost low because you're not going to be using it a lot. And for more avid enthusiasts, we have a one-time payment option. This gives you a lifetime subscription to Gyraline and you can use it whenever you want. At the track, Gyraline. On the trail, Gyraline. Grandma's house, Gyraline. Shrek's coming over, Gyraline. We came up with this pricing by listening to the car community, so we have to say thank you from the bottom of our hearts for helping support this project. Gyraline wouldn't be where it is without you guys, so if you want to try it out, go download the app. It's free. We give you 3 free tokens to prove that the app is pretty close even without the Gyraliner, so that you have a risk-free trial before you go get your tool. We absolutely value your feedback, so if you have anything that you want to talk to us about the app, we'll have an email in the description below, and stay Gyralined.